Hi, my name is Ali Ibrahim, and this is a short video that represents my capstone project, the last course in WQU MSFE program for my batch. My group is group number 4. It consists of 3 members, myself, Ali Ibrahim, Animish Tuwari, and Gwarsik Singh Sidhu. This is my governmental issued ID. It's actually my passport. I'm using my passport since my local ID is in Arabic, and this is document enrolled in WQU file. I will keep this slide for more 10 seconds as per the rules. Okay. So the goal of our project is to implement an indicator that predicts the direction of the trend of an asset and gives a recommendation either buy, sell, or none. The model utilizes both machine learning and Harris exponent, and its importance comes from here, since using both mechanisms together will improve the efficiency of prediction as we assume. After reviewing around 20 research paper, we evaluated classic time series to modern deep learning models. We studied Harris exponent and its interpretation for medium-term trend. Harris actually introduced his exponent, which quantifies the long-term memory of time series. The value of Harris exponent is always between 0 and 1. If it is half, it represents no correlation. If it is between 0 and a half, it represents that the series behaves in a mean reverting fashion. If it is between half and 1, it implies long-term positive correlation. Later research started to implement Harris exponent in financial market because it was introduced actually for hydrology science, but using it in financial market as a tool to predict the trend of different ETFs over different windows. In our research, we continued in the same direction, but with using machine learning approach. So what is different here in our approach? Integration of Harris exponent and machine learning models, dynamic target estimation based on rolling standard deviation, and unique trading strategy to switch to an alternate position in order to minimize risk. Assumption, we have made different assumption. We actually use segmented model approach and non-segmented model approach to compare the result and outcome between both approaches. Segmented model approach is using either GBM in one branch or random forest in the other branch, while non-segmented model approach is relying on technical indicators. Another assumption that the upper bound is the current day price plus 1 standard deviation, and lower bound is the current day price minus 1.5 standard deviation. We have used Python 3 as a programming language. It's open source and it has provided us with all useful packages. We have also used Excel sheet for storing data after downloading or manipulation. The peer review feedback, we have gained a lot from the feedback given. Initially, our objective of the research was not outlined clearly. We have corrected that. And also our scope of the work was very wide. Then we worked on that and made a narrow down for the objective and added a workflow indicating the work plan at different stages. Also incorporated a proper trading strategy. The summary of the results: we have downloaded the data for S&P 500, SSE composite indices, SPDR gold share, and Bitcoin. Data were downloaded from Yahoo Finance from January 2011 till the end of December 2020. We have tried different window sizes in calculation of Harris exponent. We tried 100, 200, 300, 400. We found that Harris exponent 400 is very volatile, so we have ignored it and didn't use it. So we are using 200 as the optimum window for Harris exponent. After that, we plotted the trend ratio variable and zero crossing rate variable, and then estimated the threshold for Harris exponent as 0.6 for gold and S&P 500 and SSE, and 0.735 for Bitcoin. Among these assets, we found that Bitcoin is behaving most differently since it is being a new emerging asset. The technical indicators, we have used TA Python library to generate a momentum, volume, volatility, and trend indicator. Additionally, we have added also a simple moving average, maximum, minimum, and ratio of minimum to maximum, and standard deviation. Scikit-learn was used to develop machine learning, random forests, GBM and XG both models. We found also that Harris exponent based on segmented approach modeling result in higher gain than non-segmented approach in 4 out of 6 for S&P 500, 5 out of 6 for gold, 3 out of 3 for Bitcoin. So my contribution during the module 1 to 5, we have adopted a policy of parallel work where every member in the group had to search and bring 5 to 10 papers, and then we make a short list and refine the papers and do the initial draft. Then enhancement and reviewing, and then a reduction of plagiarism. In the coding part, we changed our policy to split the work. Since the code can be split into modules, we almost split it equally between the team. Overall, our strategy was to play on each other's strengths to make a professional output. Conclusion of the project: that use of Harris exponent together with machine learning models add a value to our analysis. Segmented based models outperformed the non-segmented ones for S&P 500 and gold. Both segmented and non-segmented approach performed equally for Bitcoin. For future scope of the work, we are planning to publish our paper as a working paper, but of course we need to do some fine adjustment for it. Finally, I would like to thank WQU for giving me this opportunity to develop myself and learning. Thanks a lot to everybody. Goodbye.